Hi, everyone. Just wanted to take a moment to go over the third and final type of rigid transformation, or congruence transformation, if you've heard that terminology. And this is going to be the rotation. So this is kind of the turn, right? So we had the translation, which was the slide or the glide, the reflection, which was the flip, and now we're at the turn, the rotation. So ultimately, what we're going to do in this particular section is we're going to look at what rules of rotation exist to rotate points about the origin in clockwise and counterclockwise directions. And then we're going to also use those rules and other information to rotate points about any point in clockwise and counterclockwise directions. And we're going to use graphing technology to help with that second part because they're a little bit complicated. So, what is a rotation in of itself? Well, again, it is your turn, and you're turning the figure about a fixed point called the center of rotation. The most typical center of rotation is the origin. You don't necessarily have to do it about the origin, but most of what we focus on is going to be about the origin. And again, the origin is 0, 0. Um, an object and its rotation are the same shape and size. However, they might be in different directions, obviously, since you've turned it, right? So this point goes over here and then down here and then over here, all right? Or in this case, it goes the other direction. And you can do it either counterclockwise or clockwise. Again, counterclockwise would be if we went this way, that would be counterclockwise, and clockwise would be if it went this way. Okay. Um, the most typical thing that we're going to be dealing with is counterclockwise about the origin. All right. So the other piece of information that we do need to be careful of is that clockwise or counterclockwise, when you're dealing with 90 degrees, that just means you're essentially going from quadrant one to quadrant two, or you're moving one quadrant. All right. 180 means you're moving two quadrants, right? So if you were in one, you're going to end up in three. If you were in two, you'd end up in four. If you were in three, you'd end up in one, and so on and around. And then finally, 270 is where you go three quadrants. So if I started in three, I'm going to end up in four. If I started in two, I'm going to end up in one. Okay. Well, depending on which way we're going, I'm going counterclockwise. And if I started in three, I'd end up over here in two if I'm going counterclockwise, and so on and so forth. All right. Important note, unless you're otherwise being told, you're generally going to be going counterclockwise and about the origin, unless it is explicitly stating otherwise. That is going to be your go-to, just so that way we keep it clear. Okay, so clockwise versus counterclockwise. As stated, counterclockwise is the most common, and it is the general one. In general, in math, we are dealing with going from left and around, right? So we're going like that. Um, However, clockwise does sometimes happen. And you will notice there are a few pieces of information that are important and helpful for you, right? So if you go 270 degrees counterclockwise, it's the same as if you just went 90 clockwise, right? Because remember, 270 I said was the same as moving three, so one, two, three, and then 90 was the same as moving one, so right one, so they end up in the same spot. So 90 degrees counterclockwise is the same as 270 sorry, 90 counterclockwise is the same as 270 clockwise, and then 270 counterclockwise is just 90 clockwise. All right, so they mean the same thing. 180 is just 180, right? If you're moving two, doesn't matter if you're moving to left, it doesn't matter if you're moving to right. Um, they are the same. All right. So the other way you can remember this, counterclockwise, that's if you were going left, and then clockwise is if you're going right. All right. So how do we actually do these? Well, we have some rules that we can follow to help us. Now, these are rules that exist for going about the origin. So that way you can just easily figure out the points. As I said, if you're not going about the origin, we're going to be using graphing technology to help you. So 90 degrees counterclockwise, 90 degrees clockwise or 270 degrees counterclockwise, you're going to follow this rule. Flip the 2 points, then make the one on the right negative, right? So xy becomes y negative x. 180 counterclockwise or clockwise, again, it does not matter because 180 is the same as going essentially halfway around the circle. And it doesn't matter if you went half left or half right, it ends up at the same spot. So 180, you just change the sign of both coordinates. They both become negative, or they become the opposite sign. So if they were both negative, they'd become positive, and so on and so forth. So 90 degrees counterclockwise, which is the same as 270 clockwise, you're going to use this. XY becomes negative YX. All right. So you flip it and make the first coordinate negative. Okay. So we're going to go through examples with all of those, but these are the rules, and I recommend you kind of look back and follow along with these. So 90 degrees counterclockwise about the origin. As you can tell, we are rotating 90 degrees counterclockwise about the origin. I'm being very explicit in telling you how we are rotating, which direction, and what is your center, right? The origin is the center of rotation. You're going left with the counterclockwise, and you're going that by 90 degrees. Again, 90 just means you're moving one quadrant. So A here is still going to A prime, right? The pre-image is still going to the image. So A is going to A prime. It's only moving one quadrant, as you can tell. B is going to B prime. So it's going to the left, right? And then C is going to C prime. It's going left. Right? So again, all we do, we use the rule XY goes to negative YX. All right? So 3, 4 becomes negative 4, 3. 0, 1 becomes negative 1, 0. 2, 0 becomes 0, 2, right? Because if you make 0 negative, it doesn't change. All right, so let's actually go through how we would do this. Again, we're still going counterclockwise about the origin. We're going 90 degrees, so we're still going to follow this rule. We're going to flip and then make the first term negative, or the first coordinate negative. All right, so I'm going to flip. It becomes 5, negative 1, and I make the first one negative, right? So 1, 5, I flip again. I make the first part negative. 3, 4, I make the first part negative. 4, 1, I make the first part negative. That's it. All right? And that's all there is to it. If you were to graph these out, you would see that they each move just one quadrant to the left. All right, so what about a 180-degree rotation about the origin? You'll notice I'm not indicating left, right, or clockwise or counterclockwise, because again, it does not matter with 180. So 180 counterclockwise is the same as 180 clockwise. Right? So all we do on this one is we use the rule negative x, negative y. So we don't flip anything, we just change the signs of both. Okay? So as you can tell, P is going 2, P prime. H is going 2, L is going 2. And Q is actually the origin. And when you're trying to rotate about the origin, it doesn't change, right? Like if I was trying to rotate it about my finger, my finger's not changing, right? Nothing's changing if you're rotating about that point. So if you have a point that is at the center of origin, it does not change. So write the new coordinates below. Again, you do not flip them this time. You leave them alone. You just change the signs of them. 0, 2, 0, negative 2. Negative 2, 3, 2, negative 3, right? So the negative became positive, then positive became negative. 0, 0 doesn't change, right? That's the center of rotation. And then negative 3, negative 2 becomes 3, 2. Okay. So this one, again, you do not change because we're still just going 180 degrees about the origin. You do not change, you don't flip them. You just change the signs. You don't change the order, just the signs. So it becomes negative 5, 0. Negative 8, negative 6. Right? Because I'm just changing the signs. 3, 2. Oop. And then 6, 7. I'm just changing the signs. That's it. Okay? And now let's look at one last example. So we are now going 270 degrees counterclockwise. So Again, counterclockwise is to the left. 270 means we move 3 quadrants. And we're going about the origin. The origin is still my center of rotation. And so we are going to use the rule x, y, which goes to y, negative x, right? And if you forgot about that, you could look here. So again, we're doing 270 degrees counterclockwise. So you flip and then make the second part negative. Okay, so I'm going to flip. It gets 4, 3. I make the second part negative. Flip, make the second part negative. Flip, make the second part negative. And don't worry if you don't fully remember these. I'm going to let you use these pieces of information with whatever you're working on. So hopefully, they stick after you use them a couple times. So let's do this one. We're going 270 degrees counterclockwise about the origin. Again, I am going to flip and then make the second part negative. So this would become negative, not negative 2. I forgot to flip. It would become 6, negative 2, and I change the sign so that becomes positive. It would become 8, 3, make it negative. Negative 3, 4, make it negative. Negative 5, 0, and making 0 negative doesn't change anything, so I just leave it alone. And that is all there is to it. So, in recap, when you're doing these, follow these rules. If you are using anything other than the origin as a center of rotation, I'm going to let you use technology to help you, okay? But when in doubt, consult your rules, consult your notes, and you'll do fine, okay? Let me know if you have any questions. Have a good day.